pinnacle of your mathematical learning career right here. This is the Pythagorean and there's an outside chance. I don't know how far outside chance it is. I'm gonna look and see. Outside chance here. Usually I bring in a guest speaker. I don't see it there
It
yet.
is there, it's there.
I see it.
Is it Pythagorean?
Yeah, Edwin.
Yeah.
It's not there though. Okay, I'm gonna take a chance that you, the seventh graders, can handle it because the other seventh grade class could. I'm gonna bring in a special guest speaker that you all know, dealing with the Pythagorean theorem. Hold on just one second. We'll see if we can handle this. And it is here. Straight out of live television. Let's watch this ad. Like the volume here. This comes from a well-known movie I'll bet you've seen, the Pythagorean theorem. Unfortunately, Mr. Scarecrow is wrong, but listen up. Listen here. No, wait, do we have to watch the whole movie? There we go. The Pythagorean theorem incorrectly stated by the Scarecrow.
But the heart that you promised Tin Man, and the courage that you promised Cowardly Lion, but I'm Scarecrow today. Why, anybody can have a brain. That's a very mediocre commodity. Every pusillanimous creature that crawls on the earth or slinks through slimy seas has a brain. Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of PhD. PhD? Doctor of Theology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
There you have it. One more time. The Pythagorean theorem incorrectly stated. Doctor of
Theology. Sum of the square roots of any two sides of an isosceles.
Sum of the square roots of any two sides of an isosceles triangle.
Isosceles triangle is equal to the square root of the remaining side.
Good. Just thought I'd show you that because it's wrong. Which should ask you to bring up what actually is the Pythagorean theorem. You have heard it 1,000 times, you just did not know what it was up until today. First of all, with first things first, the Pythagorean theorem only works with right triangles. Write that down in big letters. It is only with right triangles. Only right triangles. Okay? And you will see it right here. Close this, just putting a damper on my light show here. Here is what it is. You will be able to finish this probably before I do. A squared plus B squared equals,
C squared.
well, one person knew it. That is it. That is the Pythagorean theorem. Who was looking in the book?
I'm glad it's
Okay. Now, what does a squared and b squared mean? And that's what you shall learn today, children, because you are of abnormal intelligence. Here's my right triangle. What it means is this. First of all, the letters A and B, those are the two, what we call the two legs. Those are the ones that form the right angle. Okay? In this case, it's this one and this one. It doesn't matter which one you call A or B. Generally, we call the shorter one A and the next longer one B. But it's the two legs, the two that form the right angle that have the square corner. C is always, and here's a good word for you to use tonight sometime with your parents, what we call the hypotenuse, which is the longest side, and it is always opposite of the right angle. In other words, C is this side right here. You will notice, by the way, here is Pythagorean, short, long, medium, A, B, C. It's right there. You have it in your notes, and then you have it there. And what it says is this, kids. If you know any two sides of a right triangle, you can use this formula to figure out what the third side is. If you have any parents who are in construction at all, probably even in farming at all, they have used this many, many, many times. Construction people use this to figure out how to make walls square. Okay? How to lay out square walls, you can always use the Pythagorean theorem. All you need is a tape measure. And you can measure out, make sure that things are perfectly square, perfectly right angled there. Taylor?
Under
Hypotenuse. It says the longest side opposite of the right angle.
Okay.
So here's your right angle. The C is always that longest side. Okay? Now let me give you a for instance here. Here is my triangle. Do another one here. Okay? Let's say this side is 3 feet and this side is 4 feet. How long would the hypotenuse of that triangle be? Well, we do it in our little formula of a squared plus b squared equals c squared. If I fill in the numbers, 3 squared plus 4 squared has to equal whatever the hypotenuse squared is. What is 3 times 3, Gabby? What is 4 times 4, Ava? And if you add 9 and 16 together, you get 25. Now here's where the thinking part comes around. 25 equals c squared, which means what number times what number gives you 25? It's a good time to talk about this. If c squared equals 25, the letter c equals the square root of 25. And the square root of 25 is 5. 5 times 5 is 25. Let me throw a couple things at you here. If c squared equals 18, what does c equal? If c times c equals 18, then the letter c equals, now you'll see the pattern here, the letter c equals the square root of 18. If c squared equals 21, what does c equal? Give you a little hint, it's c equals the square root of 21. If x squared equals 15, what does x equal? X equals the square root of 15. Do you see the pattern here? When you have a number or a letter squared equal to a number, to get this not to be squared, you just put the number and you make the other one a square root. Because this really says x times x equals 15. Well, what is that when we do x times x? That is taking the square root of that number to find out what number times itself gives you 15. How about this? A squared equals 3. What does A equal? Sam?
1/1.
A equals the square root of 3. Nobody's catching my pattern yet. I guess if I do this enough, somebody will. M squared equals 13. What does M equal? Ava? M equals the square root of 13. B squared equals 19. What does B equal, Holly? The square root of 19. Q squared equals 100. What does Q equal? Morgan?
Square root of 100.
Which in this case there actually is a square root of 100, which is T squared equals 8. What does T equal, Zach? T equals the square root of 8. Is there a square root of 8? No. B squared equals 17. What does B equal? Taylor?
The square root of 7.
The square root of 17. You get the pattern there. What you're just doing there is taking away the square, making a normal number, and moving, really what you're trying to just know that that's what happens there. Okay, how about this one? R squared equals 1,322. What does R equal? What does R equal? Grace? Make sure you get that. It's the same no matter where you go. We're not going to talk about cubes. We're just talking about squares here, if that's what you're going to ask. Where you were going with that? Ashley?
If you find the square root of a number, like if it's irrational numbers, then how do you find the size?
Use a calculator. You can just leave it as you can leave it in square root form as long as it's as simplified as it gets. But don't worry about that. We'll get to that later. Now, you needed to know that because everything that the Pythagorean theorem does deals with that. Because here's what's going to happen. Let's do this. Let's say one side is 3 and the other side is 5, and I want to know what the hypotenuse is. Still using the formula a squared plus b squared equals c squared. Well, 3 squared plus 5 squared equals c squared. 9 plus 25 equals c squared. 9 plus 25 is 34. And if I asked you, if I said c squared equals 34, what does c equal? Did we forget already? Do I have to go through this whole thing? Thank you. And the problem with this is, there is no perfect square root of 34. It's an irrational number. It's a decimal that goes on forever. It can be simplified, but we're not at that point with you guys yet. And Ashley asked, what do we do? You know, in this case, you just write that side is the square root of 34. Now, that doesn't mean you shouldn't have some idea what the square root of 34 is, because you should be able to tell me it's about something. So the square root of 34 is about, and the way you figure that out is you think about what perfect square roots do we know. We do know the square root of 36, which is close to that, and we do know the square root of 25. So you know that this has to be somewhere between 5 and 6. And for right now, that's good enough for you. Okay? You don't need to know the perfect numbers right there, but that is the square root of 34. How about this one? I have a triangle that is 3 inches by, I don't know. Yeah, 12 inches, why not? The Pythagorean theorem says a squared plus b squared equals c squared. A squared is 3 times 3. B squared is 12 times 12. C squared, what is 3 times 3? 9. What is 12 times 12? That's gross. What is 144 plus 9? 153, thank you. If c squared equals 153, what does c equal? Look at how easy that was. This is the square root of 153. C equals the square root of 153. And again, there is no perfect square of that, but you should be able to figure out it's kind of close to what? Well, you know 12 is 144. 13 is 169. So it's got to be between 12 and 13. And by the way, it has to be bigger than 12. Because there's no way that this line is shorter than 12. Because if it was shorter than 12, it would end up being shorter than this line, and you wouldn't get a right angle triangle there. Question?
Yes.
Yes, Josh.
So if it like says do the Pythagorean theorem on our page, should we write this triangle on our papers?
Yes, you always sketch out the triangle. If they give you a triangle to sketch out.
Okay.
This is the Pythagorean theorem. Sam?
Do we have to write that whole entire block of?
Only if you don't want to get a bad grade and don't want to do the whole assignment the next time. Now, let's test this out here, kids. What do we have that we know is square? You know that your paper is a square piece of paper, which means if I draw a diagonal from one corner to the other corner, I end up with a right triangle. I know the size of my piece of paper. What is the size of a piece of paper? Anybody know?
Isn't it 11 by
I believe it's 11 inches by 8.5. So if this is true, I should be able to tell you the distance between this corner and this corner. We're going to actually check it out. Now, granted, you kind of need, well, you don't really. Let's just do it. So I know a squared plus b squared equals c squared. A squared, let's just make that 8.5. While I'm writing this down, somebody do 8.5 times 8.5 really quick, will you? How about one of the good students? 11 times 11 I know is 121. Does anybody know what 8.5 times 8.5 is? Somebody giving it to me? Do I have to do everything on myself? Somebody's calculating. What's a big race? Big race. 72 1/4, is that what everybody else got?
Yep, sure.
I'm so smart.
Yes, 72.5.
Okay, so with that being said, if we add 121 and 72.25 together, 39, you get 193.25. Ooh, look at this. Equals c squared. Who's going to jump out? Caroline, if 193.25 equals c squared, what does c equal?
The square root of 193.25.
Alright, now, because, and again, I'm not a believer in calculators unless you end up with something like this. And they don't give you a lot of this. More to this. Here we go. Whoa.
Whoa, whoa. Dave walks in. Dave did it. Dave did it.
How do I get out of this?
Click the click the magnifying glass.
How do I undo this thing? I have no idea where my stuff even went.
Click the magnifying glass.
Don't actually touch it.
There's your stuff. Now fix it. Your mouse is lower. You gotta move your mouse. Oh!
Does that mean there's no
This is ruining my whole.
Hole in the wall. Oh no!
Wait. Here we go.
Oh, good.
100, what was it? 193.25?
Yes.
193.25, the square root of 13.9. Let's check this. We can actually do this. Colton has got his piece of paper there. I'm going to grab, it's almost 14 inches, should be the rule. 13.9. I think my ruler only goes up 12 inches. Colton, a lot of pressure on you and me on this. We're going to measure diagonal without Sam making noise. Yeah, next here we go. Colton says. Wait, should we no, it's only 8 by 11. It's only 8 by 10 long. Does anybody have a big piece of paper with a regular? Oh, let me see if this is right.
Organ.
Like this, like the organ.
Yes, there it is. There we go. This should hopefully be about 14 inches. Yep, look at that. 13.9 exactly. Now,
Oh wow, you got it exactly.
hold on a second, I'm gonna try and get the screen back to the usual mode here.
I see it.
Alright, since I can't finish that and you're all listening, so here's what I want you to do for tomorrow, we're gonna pick this up tomorrow because I'm not done discussing it. But what I want you to do, I really don't know yet. You're not helping yourself out. I want you to do set 20, the odd number problem. Set 20, odd. I know, but we didn't do it. This is set 20, it's actually the set from before. Too bad. Set 20, the odd number problem. Well, I try to figure out why.
Yeah.
I do mean less than 20.